So I'll start off a little bit of an introduction to myself. My name is Rory Hanratty. I am an architect of sorts, I guess. I've been working on the DEFRA project for the last 2 years. Previous to that, I have worked on various different projects in and around the universe. I've worked in insurance, I've worked in banking, I've worked in healthcare sector, and I've seen some things you people wouldn't believe. I've gone through basically every branch of software delivery that you could possibly imagine, from waterfall through Wagile or Waterfail, through actual real life agile delivery projects. You can have a look at some of my inane ramblings on the internet webs at blog.penguin.pro. You can find my Twitter and stuff like that on there. So that should all be good. So what am I going to talk about this morning? So the main gist of what I'm going to discuss is testing. Now, I know the guys have probably spent a good bit of time talking about hows of testing and sort of what it is that you're going to test, and you probably get into a bit more detail in that over the course of the next few days and stuff like that. So what I'm here to do is to give you a bit of an overview of the why bother doing testing, and also who it is that is responsible for doing it. So, I mean, on the face of it, testing, sort of in a cynical kind of a way, basically provides you with a list of the things you failed to do properly, which is kind of disheartening. It highlights the fact that we're all not super awesome software engineers, but that's something to bear in mind. Nobody knows everything, and nobody's perfect. And often, when you're working on projects, building out a piece of software, what you're actually trying to do is put together a series of experiments that you hope will deliver a working piece of software at the end of the day. But it's a good question to ask. Everybody talks about doing testing, and testing's important and all the rest of it, and you kind of tend to leap straight into the idea that we must do testing, and here are the things you must test. But let's ask the question of why. Why bother doing testing? What cool stuff do we get from testing? And quite often on projects in the real world, you can find yourself in a position where sometimes you get pushed to not do testing. There's certain pressures and realities that exist in projects around scope versus cost versus quality. And this is an old school kind of project management triangle. There's some people have turned it into a diamond and stuff as well. It's kind of, but it's useful to illustrate the point. So what we have here is up in the top part of this fabulous looking pyramid are features. So basically lots of screens, lots of things that the customer would like to see as part of their delivered application. In the bottom left, you've got money, basically. How much money do you have to spend on getting all of the stuff that you want? And in the lower right-hand part of it, what looks like a badly drawn version of Gandalf's pipe from Lord of the Rings, it's actually supposed to be a tick mark to indicate quality, is basically the quality of what it is that you're delivering. So sometimes, and most often, in reality, we don't have unlimited monies. There's a fixed budget for stuff that we're delivering, especially in the Gov projects that we work on. Sometimes you're basically looking at a fixed budget. There aren't endless coffers. Money does run out, as you can see from Greece possibly getting dumped out of the Eurozone and all the rest of it. So cash is fixed, and based on that, sometimes you have to make a choice. Do you go for building more stuff, or do you go for building things that are not terrible? People wouldn't usually describe it as not terrible, but they kind of mask it in language like, we're going to reduce the spend on quality assurance or reduce their test coverage because, we feel that we're awesome software engineers and it's all good. Forget about it. I want more stuff. So what I'm going to do is I'm going to look at a very extreme example of this, where let's play through the idea of what would happen if we prioritize features over quality. So planes of software, right? They have guidance systems, they have navigation systems. They kind of did away with the whole kind of fly-by-wire type stuff, and software controls a lot of things. This controls the flaps, controls the engines, the internal systems, all the rest of it. There's a lot of redundancy and stuff built in there. But what if we decided that actually, you know what? You don't want to focus on that cool stuff like making sure that it works okay. Let's add in more features. Let's add in the ability to beam ads directly into people's brains. Let's have stand-up toilets. Let's have 90% less pilots and 102% more things that you can buy in the plane. And we keep building these stuff. We'll add it on and we put in more and more things. So maybe you get all the bells and whistles and stuff like that, but it's maybe not such a good plan. Kind of sounds bad. It could kind of go wrong. Maybe all those new features that you put in without testing could result in your software doing something that you didn't quite expect it to do. So like I mentioned earlier on, software development is a series of experiments. And like any scientific experiment, what you need to do is you need to conduct an experiment with a means to measure the results, to assess the effect of what it is that you've done will have on the system that you're building. So I'm going to briefly cover a couple of pyramids. I think the guys are probably going to dive a bit deeper into the first one that I'm going to show you. So this is Mike Cohn's testing pyramid, basically. It's kind of a classic thing now. If you Google this, you can read up about it and stuff like that. It's referenced all over the place. You'll see it quite a lot. But essentially what this boils down to is that you spend more time and effort implementing the tests that are less brittle and easier to maintain. There's a lot of reasons for doing this. Essentially, in a sort of modern software development world, what we're trying to aim for is continuous delivery and continuous deployment and short feedback loops between our experiments being built and those going live to people who want to use your system. So in this example, you spend more time on unit tests. So unit tests are the kind of basic fine-grained building blocks of making sure your application does what it needs to do. So if I have a function that adds together two numbers and I feed in 1 + 1, does 2 come out, or does it return with a picture of Kanye West being terrible at Glastonbury? So that's the sort of tests that you write at unit tests. API and integration tests, performance tests, and security tests. It's kind of testing the glue in your system to make sure that components can speak to each other, make sure that they run appropriately under load and all that kind of good stuff. Then you're testing journey and flow through your application. So can I navigate from one screen to another? And the difference between, say, flow testing and unit testing is that there's a maintenance overhead, there's a cost. So the more flow tests that you have, the cost of maintaining those as your application morphs and evolves becomes more expensive. And then lastly, you kind of do manual testing. And that's useful. Humans do weird things. So sometimes you need to make humans do weird things in your system to make sure you're testing it properly. But that's not quite enough. So just breaking up your approach to testing into this kind of standard pyramid of, test categorization it's a start, but sometimes it's not quite enough to make sure that you're doing things properly. This is the other pyramid. I'm not quite sure what it's called, to be honest, but where it comes from is a book called 50 Quick Ideas to Improve Your Tests. It's a kind of a series of books. There's another one called 50 Quick Ideas to Improve Your User Stories. And there's also a book by the same guy called Impact Mapping. I'm not going to pronounce his name because it's difficult to pronounce, but Google those as well. I can't recommend reading those things enough. There's some super cool stuff in there. This is sort of loosely based on, it's analogous to Maslow's pyramid of needs. If you don't know what that is, Google it. It's about the kind of basic things that a human needs to survive, pretty much. So these are the basic things that need to be in place for a software development system to be useful and usable and deployable and all the rest of it. So this kind of maps onto Mike's pyramid of the type of tests that you do, but this actually gives you more of an idea of what it is that you're trying to prove when you're writing tests. So it makes you think a little bit more about the context in which you're doing things. So at the very bottom of this, you need to spend significant effort on writing the sort of tests that make sure that your system is deployable and that functionally it behaves the way that you expect it. Because it's no use writing software if you can't put it anywhere to run. Works on my machine is kind of sweet when you're writing code and you're bashing away and you're being, the most heroic developer in the universe. But that pendulum swings entirely the other way if you try to deploy it somewhere and the server that it's running on goes on fire. So you need to invest heavily in those sort of tests. The next level above that is checking, is the system performant? Is it secure? So these are the sort of things that are visible to the outside world, and you will end up on the news if you don't do this. So brilliant. I built an application, and with just me using it, on my machine or just with a team of people using it on a development environment, it seems super fast. But what happens if we put it into production? What happens when 100 users are using our system? What happens when 300 users are using our system? Or, for example, on one of the projects that we worked on, IER, what happens when Facebook put an ad at the top of a page to tell people to go and register to vote, and that drives tens of thousands of people at your application? If you haven't written tests to do those sort of experiments up front, when you put that into a live system, you're leaving yourself exposed to huge risk, and it can be quite a difficult thing to deal with if your system's not performant. If people can't, for example, make applications to get their passports to go on holidays, that ends up in the BBC News, and that's not a cool place to be. Similarly, one of the other kind of newsworthy things that can happen to your system is that it can be compromised. So there's countless examples of this over the years. All those poor fools with PlayStations suffered massively when Sony got hacked, and all of the login details for people who had PlayStations were basically available on the internet. Anyone could grab them, payment details, the whole lot. Again, you're on the news. So how do we mitigate against that? Well, we do stuff like security testing and penetration testing and stuff like that. So it's really, really important. So once we've made sure that we can deploy our application, we need to make sure that it's safe and secure and will actually run with the volumes that we anticipate. And that's all very easily covered with the sort of testing that Mike's pyramid mentions. Now, that's all well and good from a functional point of view, but then you start going a little bit beyond that, the sort of stuff that's a little bit more intangible and less easy to measure. So for example, is the system usable? Can people get from point A to point B? Did we somehow make an horrific mistake with our CSS and have a white background with white text on it? We can test those sort of things. Are the images placed appropriately at the page? Can people navigate through easily, or have we made a mess of styling and all the rest of it? So that's something that you actually need to test as well. And that's not something that's easily testable using automated testing. And this is where things like user research and customer insight come into play. So you need to start actually going out and talking to the people that use your system and find out, is what you've built, is it usable? Can they do what they need to do? And that's the next most important question that you need to ask as well, is what you've built useful? Are you solving a real useful problem? And sometimes that's a question that people don't ask enough. And asking that question early on, when you're kind of almost specifying the tests that you're going to perform on a system or on a user story or a unit of work that you're going to build, is very important, because it might actually stop you from embarking on a world of work that ultimately can be pointless. So you need to test, is it useful? So that's asking questions up front about the value that you're going to deliver with this, and also measuring the outcomes on a live running site. So now we're into the realm of things like analytics and so on. So you can check, have people click through certain routes in your application? What's the conversion rate if you're running a site that sells things, that sort of stuff. So you can find out, actually, is this useful? Have we solved a problem for people? And then successful. So we built something that's usable, seems to be useful. Is it successful? Do people manage to do what it is they started off to do on your site? So say, for example, if I want to register to vote, how many people start off on that journey to register to vote and get from the first page to the last page where they get a success indication to say that, cool, super sweet, you now are registered to vote, you're going to get a letter in the post? And again, that's all stuff that we can measure with things like analytics and setting up journeys and funnels and so on through our application. So it's an awful lot more than the sort of the old idea that all we do is write unit tests, lob it over a wall, and then that's somebody else's problem. So who writes tests then? Because all this stuff, that's a lot of work, and maybe I don't really want to get involved in all of this. So kind of pity the fool that ends up having to do this. So surely it's some sort of skilled genius that gets to do all this kind of stuff, because that's the way things used to be done. You would have developers who would prepare the code canon, because that's what we are. We're awesome developers, and we're going to blast our code across the universe at the test team, and those suckers can sort it out. But that's not maybe the best way of going about things. There's something not quite right about that. Maybe as a developer, when I write some code, it's likely that I know a fair amount about the implementation. So maybe some of this is my problem. But then again, as a QA person, I've maybe got more of a view about the context in which people are developing the software. I've got a mindset about how to effectively test software. So maybe as a QA person, I should do this. But then the developer, she wrote the code. She knows where some skeletons are buried. She understands what she's covered with her testing. So maybe if I work with her, I could figure out what testing that I need to do. And then when you continue along this line of thinking, then obviously the product owner or the stakeholders who asked for the software in the first place, they kind of know what it was that they wanted from this, and they're going to have to sign off on this. So maybe they need to do the testing, or the BA, because clearly a business analyst, she also had quite a bit of an input into this. So maybe she should be involved. You can kind of see where this is heading, right? It's heading to a terribly badly altered slide that says everyone writes tests, right? Because when you think about it and you follow through on the kind of the thinking that I was doing on the previous slide, is that everybody on a team can bring their own particular insight and their own particular thinking to how it is that you should go about writing tests. So it's a team sport, as with everything in kind of agile delivery and so on. It's all about the team. You could almost do a parallel talk about the sort of ops side of the team, the whole DevOps thing. The same works for testing. I mean, there's probably not a good word for this, which is, dev test ops or some mad stuff like that. But it's essentially, it's a team sport. The more people you have involved, the more likely you are to ask the right questions, to put the right tests in place, to ignore the things that don't really matter ultimately at the end of the day. So that's what we're trying to do here. We're trying to build the right thing. So ultimately, that's what testing is about. We're trying to build the right thing to make sure that what we're doing is we're covering all of the things in the pyramid of ultimate greatness, basically. Does it work? Does it handle volume? Is it usable? Is it successful? And so on. So without tests, we can't really answer any of those questions. And without working as a team to figure out what those questions are in the first place, we're not going to get those questions right in the first place. And that, for me, is why testing is so important on projects, and why it is that I believe that everybody should be involved in it. So that is the presentation part of this done. If you guys want to ask some questions, Damien and Simon, you can probably relay them to me on Skype if you like. I'm not quite sure how this Hangouts thing is going to work in terms of doing the QA stuff and all the rest of it, because I can't really see who else has joined in here. So any questions, fire them to me on Skype, and I can answer them on there. So first question is there any pen testing in Kainos? That's a really good question. Nice one, Neil. Yes, there is. So on the Gov project, certainly, we have Pavo and Daniel, who form the kind of security capability. And those guys work either embedded on the projects or as kind of floating consultants that move around projects and do pen testing on things. So what we have is we have automated testing tools that we use and run against deployed platforms, which is quite cool. And also they kind of do manual kind of interventions and things and so on. So typically what you'll have is that as part of developing a new feature or a new story or so on, we would consult with the security guys on some of our assumptions about how we would deploy things and the sort of security aspects that we would need to put in place, like validation of inputs, limiting endpoint accessibility to certain IPs or whatever it happens to be on a running platform. And then separate to that, pen testing events happen. You'll also find that on some projects, external pen testing will go on. So it's usually a good idea for you to kind of ask up front for the guys to come along and do that sort of thing. So, yep, good question. Okay, cool. if there's no more questions, what I'll do is I'll stop the broadcast. I'm hoping that this is actually recorded, so you can, if you're, if you're a sadomasochist, you can come back and look at this again in your own time, and see if I've said anything particularly weird or mad. But in the meantime, thanks for taking time to have a listen to what's going on, to what I was talking about this morning. Any questions at all that come into your brain or whatever afterwards, honestly, feel free to email me or whatever. The guys can give me an email address, and I'm happy to talk about this stuff anytime at all. So yeah, enjoy the rest of your course, and yeah, hopefully I get talking to some of you guys in the future. Cheers.